All right, folks, let's talk about roads. Roads are an essential part of our daily lives, connecting us to places and people. But have you ever wondered what makes a road durable and long-lasting? We all use them, but most of us don't think about what goes into making them last. It's not just about the surface, you see, there's a lot more happening underneath. Just like a house needs a strong foundation, a road needs a good base course. This is the layer that ensures everything stays in place and functions as it should. This layer sits between the subgrade, the soil underneath, and the asphalt or concrete you drive on. It's a critical component that often goes unnoticed, but plays a vital role. Think of the base course as the unsung hero of the road. Without it, the road would quickly deteriorate under the weight of traffic and environmental conditions. It might not be glamorous, but it provides the support and drainage needed to handle traffic loads and prevent cracks. Proper drainage is essential to avoid water accumulation, which can weaken the road structure. A well-designed base course means a smoother ride, less maintenance, and a longer lifespan for the road. Imagine driving on a road that remains smooth and crack-free for years. That's why getting the mix right is crucial. The right combination of materials ensures the base course can withstand various stresses and strains. We don't want any shortcuts here, folks. Cutting corners might save time initially, but it leads to bigger problems down the road, literally. We're talking about doing it right from the ground up. Every step in the construction process is important, from preparing the subgrade to laying the final layer of asphalt or concrete. A poorly designed base course leads to potholes, cracks, and costly repairs down the line. Nobody wants that headache. Potholes not only cause damage to vehicles, but also pose safety risks. So whether you're building a driveway or highway, remember that a solid foundation is key. It's the difference between a road that lasts and one that needs constant repairs. Let's get into the nitty-gritty of designing the perfect base course mix. We'll explore the types of materials used, the importance of compaction, and how to ensure proper drainage. Stay tuned as we dive deeper into the science and engineering behind building roads that stand the test of time. Before we even think about mixing gravel, we need a game plan. This game plan is crucial because it sets the foundation for everything that follows. Without a solid plan, we risk running into unforeseen issues that could delay the project or even compromise the quality of the road. Just like every house needs a blueprint, every road needs a design that considers its specific needs. This design isn't just about the layout, it includes every detail from the materials to be used to the environmental factors that could affect the road's longevity. This starts with understanding the project requirements. First up, traffic. We need to conduct thorough traffic surveys to understand the volume and type of vehicles that will use the road. This data helps us determine the road's capacity and the kind of wear and tear it will endure. How much weight will this road be carrying? The weight of the vehicles, especially heavy trucks, plays a significant role in the design process. Roads that carry heavy loads need to be built with stronger materials and a more robust structure. A quiet residential street is different from a busy highway full of trucks. Residential streets may only need a simple design, while highways require more complex engineering to handle the constant heavy traffic. We need to make sure the base course can handle the load without budging. The base course is the layer that provides the foundation for the road, and it must be compacted properly to ensure stability and durability. Next, we look at the subgrade. The subgrade is the soil layer beneath the base course, and its quality can significantly impact the road's performance. What kind of soil are we working with? Different types of soil have different properties, and understanding these properties is essential for designing a road that will last. Is it sandy, clay-like, or something else? Each type of soil has its own challenges and advantages. For example, sandy soil drains well but may not be as stable, while clay soil can be very stable but may retain water. Different soils have different load-bearing capacities. We need to test the soil to determine its strength and how much weight it can support. We might need to improve the subgrade before laying the base course. This could involve adding materials to strengthen the soil or using machinery to compact it more thoroughly. Finally, let's not forget about Mother Nature. What's the climate like? The local climate can have a huge impact on the road's durability and performance. Heavy rain, freezing temperatures, or scorching heat can all impact the performance of the base course. We need to consider these factors when choosing materials and designing the road. We need materials that can stand up to the elements. This means selecting materials that won't degrade quickly under harsh weather conditions. By carefully considering these factors, we can start selecting the right materials and designing a mix that's built to last. This ensures that the road will be safe and functional for many years to come. Remember, preparation is key to a successful project. A well-prepared construction site and a detailed plan can make all the difference in the quality and longevity of the road. Now, let's talk about the good stuff, the materials that make up a strong base course. It's like choosing the right ingredients for a recipe. The right combination will give us the desired strength, stability, and drainage. Crushed stone, gravel, and recycled aggregates are the workhorses of base course construction. Crushed stone, usually granite or limestone, is known for its strength and durability. Gravel, a mix of rock fragments, offers good drainage. Recycled materials like crushed concrete or asphalt are eco-friendly options that can be just as effective. The choice depends on several factors, including availability, cost, and the project requirements we talked about earlier. For example, in areas with heavy frost, we might choose a material with excellent drainage to prevent frost heave from damaging the road. Remember, not all materials are created equal. We need to make sure we're using high-quality, clean materials that meet industry standards. Using subpar materials is like building a house on a shaky foundation. It's just asking for trouble. Section 4, getting the right mix, gradation and particle size. We've got our ingredients. Now let's talk about proportions. In base course design, it's not just about what you use, but how you use it. That's where gradation comes in. Gradation refers to the distribution of different particle sizes within the mix. Imagine a jar filled with only large rocks. There would be lots of empty space. Now, imagine adding smaller stones and sand to fill those gaps. That's what we're aiming for. A well-graded mix with a variety of particle sizes. Why is this important? A well-graded mix is denser and more stable. It compacts better, provides better load distribution, and allows for good drainage. This means a smoother, more durable road surface. To determine the right gradation, we use something called a sieve analysis. This involves passing the material through a series of sieves with different sized openings. By analysing the percentage of material retained on each sieve, we can determine if the gradation meets the project requirements. Section 5. Putting it to the test: laboratory testing. In this section, we delve into the critical role that laboratory testing plays in the construction of durable and reliable roads. Before we lay down the base course, we need to make sure it's up to snuff. This means ensuring that the materials we use meet the necessary standards and specifications. That's where laboratory testing comes in. These tests provide us with a wealth of information about the materials we plan to use, helping us make informed decisions. It's like getting a blood test. It gives us valuable information about the properties and behavior of our mix. Just as a doctor uses blood tests to diagnose health issues, engineers use lab tests to diagnose potential problems with construction materials. One important test is the Proctor compaction test. This test helps us determine the optimal moisture content at which a soil type will become most dense and achieve its maximum dry density. This tells us how densely we can compact the mix using standard methods. Proper compaction is essential because it affects the strength and stability of the base course. Proper compaction is crucial for strength and stability. Without it, the road could suffer from premature failure, leading to costly repairs and maintenance. Next up, the California Bearing Ratio, or CBR test. This test is vital for assessing the load-bearing capacity of the compacted mix. This measures the load-bearing capacity of the compacted mix. Essentially, it tells us how much weight the base course can support before it starts to deform. It tells us how well the base course will resist deformation under the weight of traffic. This is crucial for ensuring that the road can handle the expected traffic loads without significant damage. Finally, we have the Resilient Modulus test. This test measures the stiffness of the mix or its ability to bounce back after being compressed. This measures the stiffness of the mix or its ability to bounce back after being compressed. A higher resilient modulus indicates a stiffer material, which is better at distributing loads and resisting deformation. It's an important indicator of how well the base course will resist fatigue and cracking over time. Roads are subjected to repeated loading from traffic, and materials that can withstand this without cracking are essential for long-term durability. These tests might sound complicated, but they're essential for ensuring the quality and performance of our base course. Each test provides critical data that helps engineers design and construct roads that are safe, durable, and cost-effective. Think of it as a quality control chain. We don't want any surprises once the road is built. By thoroughly testing materials in the lab, we can predict how they'll perform in the field, reducing the risk of unexpected failures and ensuring a longer lifespan for the road.